Hello everyone, myself Ritika Tyagi. Today we are going to start our new chapter from chemistry, that is chemical reactions and equation. Class 10th, chemical reactions and equations. Let's start the chapter. Before we are starting our chapter, first we take a look index of the chapter. The first topic is the introduction. What are chemical reactions? How do we define it? Next, components of chemical reactions. Mainly two components are discussing here. First, reactants. What are reactants? And second, products, which we are discussing in this. Next, types of changes. How many types of changes takes place? There are mainly two types of changes which we are discussing in it. First, physical change, and second, chemical changes. What are the major differences between them? What are their examples? We are discussing in this. Next, characteristics of chemical reactions. How do we characterize that a chemical reaction takes place? There are mainly 5 indicators for this. The very first is evolution of gas. Second, formation of precipitate. Third, change in color. Fourth, change in state. And fifth, change in temperature. Next, balancing of chemical equations. How do we balance and unbalance chemical equations? We are discussing in this. Next one is types of chemical reactions. There are mainly 5 types of chemical reactions we are discussing in this. First, addition reaction. Second, decomposition. Third, displacement. Fourth, double displacement reactions. And the last one, fifth, is redox reactions. Seventh is effect of oxidation reaction in our everyday life. How oxidation affect our life, we are discussing in this. Let's start the introduction of the chapter. First topic of this chapter, the introduction. What are chemical reactions? How do we define it? Chemical reactions are the processes in which new substances with new properties are formed. Means the changes in which new substance with new properties formed, then these changes are considered as chemical change or chemical reactions. जिन रिएक्शंस में कोई नए सब्सटेंस बनते हो, नई प्रॉपर्टीज के साथ बनते हो, उनको हम केमिकल रिएक्शंस या केमिकल चेंजेस कंसिडर करते हैं. आर द प्रोसेस इन विच न्यू सब्सटेंस विथ न्यू प्रॉपर्टीज आर फॉर्म्ड आर नोन एज केमिकल रिएक्शंस. नोट में फर्स्ट हेडिंग, chemical reactions involve chemical changes, not physical changes. When a substance undergo a chemical change, then it is considered as a chemical reaction only. Second point, only a rearrangement of atom takes place in a chemical reaction. As we know, law of conservation of matter. Matter can neither be created nor destroyed, but can be converted from one form to another. Similar law apply here. Here it is says that only rearrangement of atoms takes place. Means during a chemical reaction, atoms can neither be created nor destroyed. They can only displace one another positions. Next, let us take a look example of chemical reaction is also given in NCERT. Example, when a magnesium ribbon is heated, it burns in air with a dazzling white flame to form a white powder called magnesium oxide. When we take a magnesium ribbon, burn in oxygen or air, then it form a white powder of magnesium oxide, and it is an example of a chemical reaction because in this reaction chemical change take place. In this reaction chemical change takes place because a new substance with new property is formed, that is magnesium oxide. Here magnesium is a metal that is solid in state, whereas oxygen is a gas which is also present in atmosphere. Now both of these combine to form a single product, that is magnesium oxide. Here properties of magnesium oxide are very different from its constituent substances. Note, before burning in air, magnesium ribbon is cleaned by rubbing with the sandpaper. It is also a question in NCERT. Why magnesium ribbon is rubbed before burning in air? मैग्नीशियम रिबन को जलाने से पहले रब क्यों किया जाता है? The reason is that As we know, magnesium is a metal and it is reactive. So it reacts with the air or oxygen which is present in atmosphere to form a hard or tough protective layer of magnesium oxide on its surface. So before we burn it, we have to clean it with the help of sandpaper. Reason: this is done to remove the protective layer of magnesium oxide from the surface of magnesium ribbon so that it will be readily combined with the oxygen of air. Means magnesium react with the oxygen of the air to form a hard protective layer of magnesium oxide on its surface. So we have to clean its surface before burning so that it can easily combine with the oxygen of air to form white powder of magnesium oxide. I hope these points are clear to all of you. Next, here is an activity from NCERT, that is activity 1.1. It is shown magnesium ribbon. It is held with the help of tongue, chimney. Next, burner to produce heat. Here, kept a watch glass. Watch glass is a container in which magnesium oxide white powder is collected. That is, magnesium oxide white powder is collected in this watch glass. Burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. It is in this activity shown. Caution, सावधानी हमको यहाँ पर रखनी होगी when we burning a magnesium ribbon. This activity needs the teacher's assistance. It would be better if a student wears suitable eyeglasses. The question is that teachers must be present when student performing the experiment. Next, students must wear eyeglasses to protect their eyes from the dazzling white flames which is produced by burning of magnesium ribbon, which is very harmful for the eyes. First step, clean a magnesium ribbon about 3 or 4 cm long by rubbing with a sandpaper. The very first step is that we have to clean the magnesium ribbon with the help of sandpaper to remove the oxide layer which is present on the magnesium ribbon, so that new magnesium metal is exposed and react easily with the oxygen of air to form a white powder of magnesium oxide. Second step, hold with it a pair of tongues. We have to hold it with the help of tongue yani chimney. Burn it using a spirit lamp or burner. Now burning the burner, collect the ash so formed in a watch glass. The ash, the white color ash which is formed during burning of magnesium ribbon in oxygen, we have to collect in a watch glass as shown in figure 1.1. Burn the magnesium ribbon, kept it away as far as possible from your eyes. During burning of magnesium ribbon, we have to kept the magnesium ribbon away from the eyes as far as possible. Means magnesium ribbon को जितना दूर हो सके आंखों से दूर रखना है. पहली क्वेश्चन, टीचर्स का प्रेजेंट होना जरूरी है. आई ग्लासेस का पहनना जरूरी है to protect the eyes. And third question is that we have to kept the magnesium ribbon away from us as far as possible. जितना दूर हो सके magnesium ribbon को अपने से दूर रख के चलाना है. What do you observe? Now, what are your observations? अब आपने क्या observe किया? The answer is that we observe that magnesium ribbon is burning with a dazzling white flame and produce a white powder of magnesium oxide which we collect in this watch glass. You must have observed that magnesium ribbon burns with a dazzling white flame and changes into a white powder. This white powder is magnesium oxide formed due to the reaction between magnesium and oxygen present in the air. These are our observations, that magnesium react with the oxygen of air and burn to produce a dazzling white flame and a white powder of magnesium oxide which we collect in this watch glass. I hope this activity is clear to all of you. The next topic, second, components of chemical reactions. What are the components of chemical reactions? There are mainly two components of a chemical reaction. The very first, reactant, and second one is product. What are these reactant and product? How do we define it? What are their examples? How do we identify? We all these questions discuss in this session. Reactants. What are reactants? The substances which take part in a chemical reaction are called reactants. The substances which take part in a chemical reaction are called reactants. Means वे पदार्थ जो किसी भी reactions में participate करते हैं, that are reactants. The reactants are the substances which are ready to undergo a change, which participate in a chemical reaction, which undergoing change to form a new product. Then these substances are known as reactants. Products. What are products? The new substances produced as a result of chemical reactions are called products. जो नया substance during a chemical reaction बना है, that is product. New substance that is produced during a chemical reaction with new properties which is completely differ from its reactant are known as products. Now let us take a look of reactants and products of a chemical reaction with the help of an example. Reactants and products. Here Mg solid, S represent the solid, O2 gas, gaseous in state. In front of arrow there is magnesium oxide, state is S, that is solid physical state. Here Mg and O2 are the reactants of this reaction, whereas MgO is the product. Arrow indicates that these two and these two are the coefficient of this reaction. What is coefficient? Coefficient is a number which we use to balance the chemical reaction. Balancing of chemical reaction we are discussing later. S, G and S represent the physical state of this reactant and products. Reactants are consumed in a chemical reaction to make products. Means reactants take part in chemical reaction and produce a new substance which we called product. The properties of product completely different from these reactants. Two equations which are shown. We have to identify reactants and products of these reactions. Here calcium carbonate CaCO3, arrow above showing a triangle. Triangle means we are giving the heat, forming calcium oxide and carbon dioxide. As we know, reactants are the substances which take part in a chemical reaction. So here calcium carbonate is the reactant of this reaction, and on other side of arrow there is calcium oxide and carbon dioxide which are formed by breaking up of calcium carbonate. So calcium carbonate and carbon dioxide, both of these are products for this reaction. Next, sodium carbonate or sodium bicarbonate decompose by applying heat to form sodium oxide and carbon dioxide. Similar here, sodium carbonate take part in chemical reaction, so it is the reactant for this reaction, and sodium oxide, carbon dioxide formed in this reaction with new properties. So these are the products for this reaction. The next topic is types of changes. There are mainly two types of changes. First physical changes, second chemical changes. Now the question is, what are physical changes? What are their examples? How do we classify that it is a physical change or a chemical change? We are discussing in it. Physical changes. It is a change in a substance that does not change its chemical composition. Instead, it changes the substance physical properties such as shape, size, color, texture. Means physical change are the changes which change the physical properties of the substance only, that is its size, its color, its shape or texture. It never altered their chemical composition. Physical changes involve only physical change of a substance, not a chemical composition change. For example, dissolving sugar in water. As we know, when we dissolve sugar in water, we get a sugar solution. But there is a method to separate it also, by evaporation. By evaporation, water evaporates and leaves behind the sugar which is left in the container. So here we can separate the components of this solution. Next, crushing paper. If we crush a paper, then we can also get it back. Next, melting of ice. If the ice is melt, then we can also refreeze it by kept in freezer. Note, physical changes usually temporary and reversible changes. Physical changes, the changes in which physical properties of a substance undergo change, not chemical changes. Physical changes example, dissolving sugar in water, crushing paper, melting ice, boiling of water, freezing of water. Physical changes are temporary and reversible changes. These points we have to be memorized. The next type of change, chemical changes. What are chemical changes? What are their examples? How do we classify that a chemical change takes place? So, the processes that alter the molecular composition of substance and create new products. Means, chemical changes involve chemical reactions. Here, molecular composition of the substance undergo a change. Alter means change. And the new substance that is formed during a chemical change is completely different from the previous one and it cannot be get back. That is, it is an irreversible change. It is an irreversible change or permanent change. Or permanent change. For example, formation of curd from the milk. If the milk converted into curd, then curd cannot be converted into the milk. Similarly, cooking of food. If the food is cooked, then it cannot be get back. Digestion of food in our body. Next, rusting of iron. When a rusting of iron takes place, then there is a formation of rust, which is a reddish brown powder, and this reddish brown powder, that is rust, cannot be converted into an iron object back again. So all these are the examples of a chemical change, because in all these examples a chemical reaction takes place which produces a product which is permanent and irreversible by nature. Similar, combusting and rooting. Combustion means burning. When we burn a substance, then it cannot be get back. It is split up into two or more substances. Next is rooting. Rooting means sadhana. If a fruit or a vegetable rooted, then it cannot be fresh again. That a chemical reaction take place, or what are the indicators which indicate that a chemical reaction takes place, we are discussing in this session. As it is shown, color change, any change in color. Gas bubbles, evolution of gas. Precipitate formation means an insoluble substance settle down at the bottom of the container. Temperature or heat change, either it is evolution of heat or absorption of heat. Next, light formation, some sparkling type. First is the evolution of gas. Second, formation of precipitate, PPT. What is PPT? Precipitate. Precipitate is an insoluble solid substance which is formed during a chemical reaction and it settle down at the bottom of the container. Third one is change in color. Fourth, change in temperature. Fifth, change in state. All these are indicators, that is total 5 indicators, easy to memorize. That is 3 involve change. 3 indicators involve change. Change in color, change in temperature, change in state. And the first one, evolution of gas. Second one, formation of PPT or precipitate. The first indicator of a chemical reaction which we are discussing, that is evolution of a gas. Some chemical reactions are characterized by the evolution of the gas. For example, chemical reaction between zinc and dilute sulfuric acid is characterized by the evolution of hydrogen gas. Reaction is shown, zinc solid in state, it is metal, react with sulfuric acid, H2SO4, aqueous, AQ indicate the aqueous. AQ indicate the state of the sulfuric acid, that is aqueous. Aqueous means it is dissolving in water. Then zinc and dilute sulfuric acid react to form zinc sulfate and release hydrogen gas during the chemical reaction which we are discussing, evolution of gas. That is hydrogen gas evolved in this reaction. It is also shown here. It is a figure of NCERT book. Here it is a beaker In it, soap solution is kept. Next, it is a stand where a test tube is held. In this test tube, zinc granules and dilute sulfuric acid react. Then here is the formation of bubbles of hydrogen gas. Here is formation of bubbles of hydrogen gas, and these bubbles of hydrogen gas are delivered into this beaker with the help of delivery tube, and there is a formation of some bubbles. These are bubbles of hydrogen gas. Detection of hydrogen gas. How do we identify that the releasing gas is the hydrogen gas? Because it has no color, it has no taste, it has no smell. Then how it is possible that we identify that the releasing gas is a hydrogen gas? So there is a test to identify the releasing gas is hydrogen. Is that hydrogen gas bubbles burn with a cracking noise, that is pop sound. When we bring a candle near hydrogen gas bubbles, then hydrogen gas bubbles burst with the pop sound. हाइड्रोजन गैस बबल फटफट की आवाज के साथ फटते हैं, तब ये कंफर्मेटरी हो जाता है कि द रिलीजिंग गैस इज हाइड्रोजन गैस. सो इट इज द टेस्ट फॉर हाइड्रोजन गैस डिटेक्शन. द डायग्राम, आई होप इट इज क्लियर टू ऑल ऑफ यू. It is an equation. We show that zinc react with sulfuric acid to form zinc sulfate plus hydrogen. Here S indicate the solid state, AQ indicate the aqueous. Aqueous means dissolving in water, and G indicate the gaseous state of hydrogen gas. Here is an activity 1.3 from NCERT book. All these activities are important from examination point of view. The very first step, take 5 zinc granules in a conical flask or a test tube. It is a conical flask. We have to take some zinc granules in it. Second, add dilute hydrochloric acid or sulfuric acid to this. Hydrochloric acid HCl and sulfuric acid H2SO4. So we have to add either dilute sulfuric acid or dilute hydrochloric acid in it. Dilute means a solution with water. Caution is that handle the acid with care. We have to handle the acid with care because acid causes severe burns when it comes in contact with our skin or with our clothes. Do you observe anything happening around the zinc granules? Observation. What are your observation now? What are you observing around zinc granules? The conical flask or a test tube, is there any change in its temperature? So the observation is that around the zinc granules there is a formation of some bubbles, and these bubbles are of hydrogen gas. Second observation is the change of temperature. When we touch this conical flask after adding zinc granules and dilute sulfuric acid or hydrochloric acid, then the temperature of this conical flask rises up, which means evolution of heat takes place. It is an exothermic reaction. Exo means release. Exo means release or exit. Therm means heat. Therm means heat. So it is an example of releasing heat reaction. Conical flask become hot because it is an exothermic reaction. So observation for this question is that temperature of the beaker rise due to evolution of heat. So it is an exothermic reaction. And the observation for this, bubbles are observed around zinc granules due to release of hydrogen gas. Zinc granules react with dilute sulfuric acid or dilute hydrochloric acid to form hydrogen gas bubbles, which we observe around the zinc granules, and the temperature of the beaker rise, which indicate that the reaction is exothermic reactions. So these two are the observations for this activity. I hope it is clear to all of you. Next, now there is another example for the evolution of gas where carbon dioxide gas is releasing. In the previous one we discussed about hydrogen gas and the detection test for hydrogen gas, that is pop sound. Now we are discussing about carbon dioxide gas. How do we detect it? What is the test for its detection? So here, chemical reaction between sodium carbonate and dilute hydrochloric acid is characterized by the evolution of carbon dioxide gas. Reaction between sodium carbonate and Na2CO3 solid in state react with hydrochloric acid HCl, aqueous in state means dissolving in water, then it forms sodium chloride salt plus water and carbon dioxide gas. So here evolution of carbon dioxide gas takes place. Here these are some figures which indicate detection test for CO2. What mean? CO2 gas is used for extinguishing the fire. First test for CO2 is that CO2 gas is used for extinguishing the fire. CO2 gas is used to put off the fire. Carbon dioxide gas is used to put off the fire or extinguish the fire in fire extinguishers. And second detection is lime water. Lime water, which is initially colorless. When CO2 gas is passed into this lime water, then it becomes cloudy or white in color. Then lime water turns milky. Lime water turns milky. These are the two detection tests for CO2. The first one is that carbon dioxide gas extinguishes the fire, which is used by fire extinguishers. And second is that when we pass CO2 gas into the lime water, which is initially colorless, then the lime water turns milky. Milky means cloudy or white in color. So these are the two tests for CO2 gas. Now we are going to discuss the second characteristics of a chemical reaction, that is formation of precipitate or PPT. In short, it is PPT. The question is that what is PPT? PPT है क्या? So a PPT is a solid product which separates out from the solution during a chemical reaction. Precipitate is a solid product which is formed during a chemical reaction and it settles down at the bottom of the beaker or container in which you carry out the chemical reaction. Example, when potassium iodide solution is added to a solution of lead nitrate, then a yellow precipitate of lead iodide is formed. Potassium iodide is Ki, react with lead nitrate, that is Pb, NO3 ka twice, and it forms a yellow precipitate of lead iodide, that is PbI2. As it is shown, potassium iodide Ki plus PbNO3 twice, that is lead nitrate, react to form potassium nitrate plus lead iodide. Here lead iodide is a PPT, yellow in color. Downward arrow shows that it is settled down at the bottom of the beaker. It is an activity 1.2 in NCERT. Take lead nitrate solution in a test tube. We have to take the lead nitrate in a test tube. Add potassium iodide solution to this. What do you observe? So what are our observation? Our observation is that there is a formation of yellow precipitate of lead iodide which is settled down at the bottom of the beaker, and we can show this equation also. So here we discuss the formation of precipitate. Some chemical reactions are characterized by the formation of precipitate. For example, between potassium iodide and lead nitrate, which is characterized by the formation of yellow precipitate of lead iodide. Here it is showing formation of yellow precipitate of lead iodide. Precipitation is the formation of an insoluble product. Precipitation means formation of insoluble product, that is precipitate, when colorless solution of lead nitrate and potassium iodide are mixed, then a yellow precipitate of lead iodide is formed. Let's discuss this, that when potassium iodide react with lead nitrate, then there is formation of potassium nitrate and a yellow PPT of potassium iodide, that is yellow in color. Here it is showing the yellow PPT of lead iodide which is formed in this beaker. So it is a yellow PPT of lead iodide or insoluble substance which is formed during a chemical reaction which is carrying out in this beaker. That's the beaker. So we are going to discuss the third characteristics of a chemical reaction, that is change in color. Some chemical reactions are characterized by the change in color. Let's discuss this with the help of an example. For example, chemical reaction between citric acid, a purple color potassium permanganate, that is KMNO4 solution, is characterized by change in color from purple to colorless. Potassium permanganate KMNO4 is purple in color. When we add some drops of citric acid or any other acid in it, then the color of the potassium permanganate get decolorized. That is, it becomes colorless. Here it is shown KMNO4 potassium permanganate. It is purple in color, as it is shown purple in color. When we add oxalic acid, formula is C6H8O7. Then it forms potassium isocitrate, that is C6H5K3O7. C6H5K3O7 and plus permanganic acid, that is HMNO4, which is colorless. So color change from purple to colorless. So it is an example for color changing reaction. When potassium permanganate react with citric acid, then color of potassium permanganate get decolorized. The second example of color changing reaction is the chemical reaction between sulfur dioxide, that is SO2 gas, and acidified potassium dichromate solution, that is K2Cr2O7 solution, is characterized by change in color from orange to green. This potassium dichromate solution is orange in color. Initially it is orange in color. But when sulfur dioxide gas is passed into it, then the color orange gets changed into green. Here it is shown potassium dichromate solution orange in color. It is orange in color. It is potassium dichromate solution. Now sulfur dioxide gas is passed into it, then the color of the solution gets changed and it becomes green in color. Here it is shown when sulfur dioxide gas is passed through the potassium dichromate solution, orange color of potassium dichromate solution changes to green. Here it is showing K2Cr2O7. We have to add some acid, that is sulfuric acid, and passing SO2 gas. Then it forms the green color potassium sulfate plus dichromate sulfate and water. It is the green color solution. The fourth characteristics of a chemical reaction is the change in temperature. Here we are discussing two types of reaction. First, exothermic, that is heat releasing reaction, and second, endothermic reactions, which we are discussing under this heading. Some chemical reactions are characterized by change in the temperature. For example, reaction between quicklime. Quicklime is calcium oxide, Kali, and water, H2O, to form slacked lime. Slacked lime means CaOH twice, that is calcium hydroxide, is characterized by change in temperature, which is rise in temperature. Calcium oxide, that is quicklime. When water is passed into this quicklime, then it forms the slacked lime or calcium hydroxide plus releasing the heat. Temperature initially low and after the reaction temperature is high. So it is a temperature changing reaction. Now it is an activity in NCERT activity number 1.4. Take a small amount of calcium oxide, that is CaO or quicklime. Calcium oxide, another name quicklime, in a beaker. Slowly add water to this. Touch the beaker as shown in figure. Do you feel any change in temperature? Yes. We feel that the temperature of the beaker rise. There is a release of heat. So formation of slacked lime by reaction of calcium oxide with water. Here showing calcium oxide CaO react with water H2O. Then these forming calcium hydroxide, that is slacked lime or lime water, with the release of heat. Calcium oxide react vigorously with water. Vigorously means fastly. Calcium hydroxide releasing a large amount of heat. Here it is showing calcium oxide solid in state, water, adding water liquid in state, then it form calcium hydroxide COH ka twice aqueous plus releasing the heat. It is showing here. Is a second example of change in temperature. It is an example of endothermic reaction. Means here heat is applied for the formation of product. Chemical reaction between barium hydroxide. Barium hydroxide is BaOH ka twice. And ammonium chloride. Ammonium chloride is NH4Cl. To form barium chloride, that is BaCl2. Ammonium and water. Ammonia is NH3. Water H2O is characterized by change in temperature, which is fall in temperature. Means initially temperature is high, but after formation of product, temperature decreases. It is an endothermic reaction, which means heat absorbing reaction. It means this reaction does not take place at room temperature. We have to supply heat energy for the formation of product of this reaction. As it is showing, barium hydroxide BaOH ka twice, when react with ammonium chloride NH4Cl, then it form barium chloride BaCl2, ammonia NH3 and water. So it is an endothermic reaction. This triangle represents the heat which we supplied for this reaction. Now we are discussing the last characteristics of chemical reaction, that is fifth characteristic, change in state. Some chemical reactions are characterized by change in state, that is from solid to liquid and liquid to gas. For example, combustion reaction of candle wax is characterized by change in state from solid to liquid and gas. Why? Because wax is solid, water formed by the combustion of wax is a liquid at room temperature, whereas carbon dioxide produced combustion of wax is a gas. So here it is showing candle, burning of candle wax, then it releases some carbon dioxide gas plus steam. Steam means bhap, water vapors. So it is liquid, it is gas and it is solid. So there is a change of state from solid to gas and liquid.